Let's take a little closer look at a company internal DNS server and if there is a separate zone set up on it. And what I mean by that is this is the same setup we have before. We have a machine right here that's on the network. We have a company has its own DNS server. And then if it doesn't know the answers or it doesn't have it cached, it will go out to a ISP DNS server. And then that DNS server will go and contact these other domains for it. It comes back with an answer, which will get to your machine. But there are times when you want to address local resources. For instance, let's say a file server or a printer or some sort of file share, and we want to address those resources and we don't want to expose that to the outside world. So what we would do is, let's use example.com as an example. So if we have our external example.com is our domain that's registered out there and we purchased the rights for example.com. And then maybe we set up our internal infrastructure as example.local. There's a few top-level domains that we can use just for private use. .local, .local domain, .domain, .lan, .home, .host, .corp. Those are some ones that we can use internal and have no fear that it's being used at all externally. And so we'll set up example.local on this local network for local resources. So that way, if I want to address the file server, then I would address file server.example.local. And then I would address that. It would go to my local DNS server. That DNS server would say, okay, that is the domain I'm in charge of because it's example.local and I have all the files for that. And you're looking for the file server. So here's the IP. It's going to return it. And now this machine knows how to get to the file server. It has the IP address to get to the file server. But let's say it's example.com now. It's trying to reach www.example.com. It gets to this local company DNS server. That DNS server says, I'm not in charge of that domain. So what I'm going to have to do, I'm going to have to forward that to the DNS server I know of. Maybe that's your ISP's DNS server. Maybe it's OpenDNS. It's some sort of other DNS server. Then that other DNS server, it could go directly to the root server. I'm not saying that's never set up that way. It goes to the ISP's DNS server, and that ISP does a lookup for www.example.com, responds back to the DNS server on your local address, and then on your local network, and then that DNS server responds back to you with that external IP address and how it resolved that external IP address. So this company DNS server acts as both a caching server for any kind of external resources, but also hosts an internal domain specifically for internal resources. And it ends with something like .local. Now, at one point in time, it was always recommended to use, for security purposes, to only use like .local, .local domain, .domain, or some sort of resources internally that is not addressable, it is not part of the any kind of external domain services that are out there. Although some more recent Microsoft documentation says use a top-level domain that is accessible from the outside, and there are some advantages, some pros and cons to choosing each one. I still, to this day, I use the internal domains like .local, .local domain, .domain, .lan for my internal domains. I still don't use what Microsoft's best practices is right now of using external top-level domains. All right, so there's actually several different types of records on a domain name server. So let's talk about a few of the different types. Up until now, we talked about host name to IP address. So for instance, if a server has let's say example.com, and you're looking for www.example.com, it's going to, within its domain, example.com, look up the record for www. And it's going to look up the IP address and send it back. We call that an A record. Or if it's sending back an IP version 6, then we call that a record, a quad A record. So that is the type of record it is, and that's translating from a host name to an IP address. There are other type of records as well, though. So there is a name server record. So that's an NS record. And name server record just says when you get to example.com and you look at the name server records, those name server records are the DNS server IP addresses. So that's a name server, just points to the domain servers that are hosting out for that domain. Then we have the start of authority. The start of authority, kind of look at this as like a control or a management records that let any of the domain controllers communicate certain pieces of information. So that's start of authority. We've got an MX record. Let's say you are sending something to, let's say example@technosurge.com. You're going to go through the domain lookup process for technosurge.com, and then you're going to look for the MX record. The MX record then will come back and say, this is the mail exchange server that you're looking for. So it's going to give you a mail exchange server address, and then you're going to be able to get to that mail exchange server address and send that email to example@technosurge.com. Then we have hostname to hostname. There are times when we want to reference a hostname. For instance, let's say we're hosting something on another site, and we want to reference that other site and send our customers to that other site. So so an example might be is maybe we're hosting something in the cloud, and we want to send all traffic to www.technosurge.com to that hosting provider. They can either give us an IP address, which could maybe change, or they give us a host name, and that host name is going to say the same, and they can point to their host name can point to any one of their servers. So we are going to say www.technosurge.com is going to this hosting provider of, let's say it's www.example.com is the hosting provider. And then the client is going to say, oh, well, now I need to resolve www.example.com to get an IP address. Now this gets a little tricky in that there commonly people think of DNS as being able to do redirects. This is not hey, I want you to actually send you to www.example.com. All I'm saying is if you go and look up www.example.com, you are going to get an IP address that I'm trying to send you. So it's just a way to reference another resource via host name rather than referencing an IP address. So that's a CNAME record. We also call that an alias record. And then we have an IP address to host name, which is the reverse, right? This is not host name to IP address. This is IP address to host name. We call that a reverse DNS because it's doing the opposite, or a pointer record, a PTR record. So this pointer record is pointing to a host name, and we do that mainly for verification. There are times when certain services need to verify an IP address. Did it receive the correct IP address? And it goes and does this reverse DNS lookup, takes a look at the IP address, and then that will come back with a host name, and then it knows it has accurate information. All right, we talked about a lot of different things. Let's just package this up and go over it one more time, but summarize everything. So this is the DNS process. You on your machine look up www.technosurge.com, and that is you're typing that into your browser. Your machine is first of all going to look at the host file and say, is this in my host file? And it's going to determine, in this case, no, it's not in my host file. All right, then I'm going to take a look in my cache and see if it's in my cache. Have I accessed this recently and it's in my cache? No, I've either not accessed it before, or my time to live on this record is gone and it no longer exists in my cache. So then it's going to go to the DNS server that's set on that machine, and it very well could be that that's the DNS server of your company. Your company is going to take a look at its cache and say, is this somewhere in my cache? If not, is this a domain that I have that I'm hosting? And if not, then it's going to request it from its forwarder or directly to the root server. So we're going to say that there's some sort of forwarder, and it now is going to forward then that onto, let's say this is OpenDNS right here. So it's going to send it off to OpenDNS and their domain name services, domain name servers. And so then that caching server is going to get it. It's going to look at its cache and say, do I have it already? If not, then I'm going to take a look at my root servers to find the information out. So it goes out and looks at the root servers, or one of the root servers. Usually this machine will have a lot of different root servers on it, and it will randomly choose one of those root servers, go out to that root server and say, who belongs to www.technosurge.com. This root server will reply back and say, I know a .com server that can help you out. So you reach out to one of the .com servers to help you out. That .com server will reply back and say, okay, well, I know where the domain server is for this. And so then it reaches out to the domain server for technosurge.com. That one looks at its table and says, I have the record for www for that domain technosurge.com. So here is the IP address that you're looking for. And I'm going to mark that this is an authoritative answer. This is the answer you're looking for. That makes it back to this server. The server sticks it in cache for any other customers that are accessing it as well. Sends it back to the company DNS server, which sticks it in this cache for anybody else inside the company that is looking for the same thing. Sends it back then to the machine itself, and that machine sticks it in its cache in case it needs to access resources again for that server. And then your machine now has that IP address. It can now reach out to that web server via that IP address and ask for the web pages for www.technosurge.com. Thanks for watching my videos. If you like them, could you hit that like button because it really helps me out.